raw percentage. And the final, you just take your raw percentage. And then you multiply by the weighted percent. And then you'll get a total value, which should give you your percentage, and this will be, and you multiply by 100 to get your percentage. So if everything works out and we didn't have any extra credit points, this value should equal 1 if you had 100% of everything. Okay? That's how it's supposed to calculate. Well, when I went in and looked, that's the way I had it set up in Blackboard. I had it set up for assignment. You use your assignment total based on however many assignment points you had, calculate 35%. Had your quiz total based on how many quiz points were there, divided by or times 35%, and the midterms. When I added the next quiz in, people's scores jumped up by like 3 or 4%. And most of you have been getting right at 90 to 100% on your quizzes. So and if I drop a quiz, it shouldn't have made any difference to the percentages. And so that's what flagged that something wasn't calculating correctly. Okay, something's not calculating correctly. So I downloaded the spreadsheet, went through and did the calculations, and even put in, a couple folks put in like a 0 for the final. Grade actually went up with a 0 for the final. And you're going, oh, that doesn't work. Something. Now, mind you, we've had an update in Blackboard in the last 3 weeks. So I'm wondering if there's something in the update that's not correctly programmed, because this didn't make any sense. So the column that seems to be goofy, and what I've done for you guys so you can actually see it, is there's an assignment percentage. Okay, there's an assignment percentage, and that's based off of the assignment, and that assignment percentage is not being calculated by Blackboard. That assignment percentage, I went out to a spreadsheet and took, because the Blackboard will show you the total available points at this point. All right, it's going to show you the total available points now that all the columns are in. But I went in and I said, all right, what's the total available points that I've put into Blackboard? And I've given you an assignment percentage, so you've got the assignment percentage that you can work with. Then I have the quiz percentage, and that's based off of 52 points for quizzes, not dropping a quiz, because we have 5 quizzes in the system. So you can take your quiz total, divide by 52, and that's what's going to be in that column. Then I've got the percentage, it's a percentage for grade, and that's calculated using this right there. 15% for the midterm, 15% for the quizzes, and everything else. Then you have a column that shows you where things are funky. It says quiz percentage as calculated by Blackboard. And if Blackboard were doing it correctly at this point, it should be taking your quiz points total, divide by 52, and give you the answer. So for example, I have, there's 44 quiz points total. Or 44 quiz points is how many what that person currently has. Divide that by 52. Gives you a quiz percentage of 84.6. Blackboard was saying that quiz percentage is 103.8.
It's wrong.
It's totally wrong. And I don't know why. I don't know why. I honestly don't know why. I'll give you another example. Got a there's another one that's 40 out of 52. And so if I do my 40 out of 52, it's going to be a 76.9. And Blackboard is saying it's 92. So I know it's in the quiz column. I know that's where the error is. It's in the quiz column. And I know that's what's been doing things artificially high. I don't know why. I honestly don't know why. It's not doing that in my other class. Blackboard is I downloaded the spreadsheet. Blackboard's calculating just fine. I don't know what it is that's doing this right now.
Just adding them? 40 and 52.
I honestly don't know. I've got a phone call into our Blackboard expert to see, but I noticed after the upgrade is when something happened. So, so right now, and it's worst case, okay? Everybody realize it's worst case because I have not dropped a quiz, okay? I have not dropped a quiz. That percentage for grade is actually calculated correctly. That percentage for grade column that's in there now is actually calculated correctly. But I wanted you guys to see how Blackboard was calculating the quizzes to realize that I wasn't intentionally making a change or anything. Things just didn't, they just, it was that gut check that said, hey, if I gave somebody a 0 on the final and their grade went up, something was wrong. That's where I'm at right now. But for most of you, what it did is it knocked you into some place that's a reasonable number instead of the weird numbers that we were seeing before.
So the number that we have now is correct?
The number that says percentage for grade, I believe, is correct.
Okay.
Yeah.
I feel like there may be an error with mine because I should have I believe, a 48 out of 52, which I calculate to be 92%, but it's showing I have like a 76 or 78%.
Well, we'll look at individual ones in a little bit. Okay, I'll take the individual ones offline, and it could be just the other thing you want to check on is make sure that what I have entered from mastering is correct in Blackboard on the individual test scores. Okay? So I need you guys over the weekend to go look at mastering and make sure that I haven't have a typo in the number to make sure that I have it correct. Which may be what your problem is right now. It just may be what the deal is at the moment. Okay? So that's so I want you guys to go in there and look so that you have a chance to, and you still have the last homework assignments still have some chance for extra credit, but remember all the extra credits going into the assignment category except for the quiz that did have extra credit on it, and that extra credit went into the extra credit on the quizzes. So that's where that one is. So double check to make sure I have everything correct so that we can take care of it. Okay? So that kind of gets us where we're at. So I apologize. It wasn't until to get the weird numbers. I've run into this before, especially when most of the grade is all assignment homework. It wasn't until you're looking at it going, okay, we're getting ready to the finish here, and I wanted to see how that grade changed with a final being added, and things went haywire with that spot. I've seen this happen, early on in a semester where, almost all your grade is assignment homework, and most of you have been getting all the extra credit on the assignment homework, so that number didn't seem unreasonable until I added a quiz that should have gone the other way. Yeah.
So I have a question. So there's two columns in my grades. It says quiz percentages,
Mm-hmm.
and it says 81.7%. Then it says quiz percentage as calculated by Blackboard.
Right.
And it's 100.9 something.
That's why I was telling you, I was showing you the column where it came from. The one that the quiz percent, not the one that's calculated by Blackboard, the one that's calculated is the actual correct one. If you take a calculator and you take your quiz points and divide it by the available quiz points, you're going to get the 81.7%. Not the 196%. The 100.96%. Yeah, if you have, if the available points were 52 points and you only have 42.5 points, you're not going to get 100% for the calculation.
I think you should leave it as like a curve.
Like I said, at this point, and the reason it really got bizarre is it wouldn't have mattered what anybody made on the final, your grade would have gone up. And that's not realistic. That's not realistic. So, so it was not an intentional distortion. I honestly don't know what's going on. But that's where, if you take pen to paper and do the calculation, you're going, okay, and then we're in an engineering class and we look at data and we go, does that data make sense? Well, that data didn't make sense. Okay. So let's get into chapter 19. So remember that next Wednesday, for those of you who are not here in our general vicinity, that next Wednesday is a day that you can take the test via Proctor. Thursday, we will do the test here. Test is targeted for less than an hour, but we give everybody 2 hours to do it. So, and Morgan, it is at the testing center. They've got it, so if you just make arrangements with them, and it's the testing center at NOC. All right. So, where are we? Yes, we are recording, according to this. We are recording. So, chapter 19, what we're going to do is impact and momentum, except now we're doing it for real objects. And so our angular momentum is just mg times our velocity of our center of gravity. So what we're going to do is we're going to look at an object. And we can do it as an irregularly shaped object. And we're going to look at a little mass I of this object. And this is about a point P. We know that if we have a rigid body, that this R is going to be constant, and we could be taking our velocity of point P can be any velocity vector that we want. And we've seen it over and over again that meant that the velocity of our little mass point I is going to be the velocity of this point P plus the velocity with R with respect to P as we're moving forward. And if we've got a rotation that we are rotating our object, this now can be related to omega cross R. So we've seen this before, and we haven't had too much problem with that. So now if I look at the angular momentum H, as defined by our stuff, it's going to be our R cross our little masses V. And if I just take it to the next step, I'm going to get my, and it works out to be I, Y, VPX plus MIX VPY plus MI omega R squared. We've done these before. But if I want to generalize for all masses, okay, I want to generalize for all masses, what this is going to be and if we remember what this is, that's just my position of my center of mass of y. That's just the position of my center of mass of x. And this is just my moment of inertia around P. So I can rewrite this as okay? And if we take H around our center of gravity, remember that it's this right here. Haven't done anything special, just wrote down H about the center of gravity. And VG about the center of gravity is VP plus omega across R. And if I do that, then I get VGX is equal to VPX minus Y bar omega, and VGY is equal to VPY plus X bar omega. Then things are hunky-dory fine. So I haven't done anything special. So we can look at motion. So if I just look for translational motion only, L is equal to mvg. And hg, since it's translational only, is 0. If I look about rotation for a fixed axis, L is equal to mvg, hg is equal to ihg, and if I go around a fixed axis, it's going to be h is going to be ig omega plus rg mvg. And that just gives us our parallel axis theorem, so we get I O omega is HL. Because RVG is just RG omega. Gives us our parallel axis theorem that goes, so about a fixed axis, we can just write that. And if I use my general plane motion, I'm still going to get L is equal to mvg, and then I can get hg is equal to ihg omega, and we can use my hic omega. So there's really nothing new here. But it does allow us to look at problems a little differently. And that's the key. So we've done the ladder problem, we've done the rod problem. So we're going to do it again. So I have either a ladder or a rod. It's 4 meters long. It's now sliding down at 2 meters per second. It has an angle of 30 degrees. This is A and this is B. We want to determine the angular momentum about the center of gravity and our instantaneous center. So one of the things we know we're going to need is omega, so we might as well figure it out now. That's 4, 2, let me write that out. That's 4. So my omega is going to be 0.5774 radians per second. And what's going to happen, here's my center of gravity. If I'm sliding this way, I'm going to get a rotation like that. And that's the rotation we've just found. If I want to look, just so we have it out here, there's my center of gravity. We know that's 2, that's 2. This is 30 degrees. When I do my instantaneous center, I've got my velocity going down, right? Which means this one's going this way, right? So I can get my instantaneous center. So there's my instantaneous center. I'm going to need this R. Okay, I'm going to need that R because I'm going to end up with a VG normal and a VG tangent. And if I do VG around the center of gravity, that's just going to be my R, which is 2 times my 0.5774 radians per second, gives me 1.155, or yeah, 1.155 meters per second. H around G is just going to be IG omega. For my bar, we know it's 1/12 the mass. And did I give this one as the mass? Yeah, this one we actually left it in kilograms. So there's the mass is 5, so mass was 5 kilograms. So my mass was 5 kilograms. And my R, or the velocity that I have going down is my 4 meters squared. No, that's my length. Sorry, that's my length. And then my omega is 0.5774. That gives me 3.85 kilograms meters squared seconds squared rotating that way. When you do this, that distance ends up being 2, by the way. So HIC equals IG omega plus DMVG. We figured that out, it's 3.85. My distance is 2, mass is 5, my 1.155, that's going to give me 15.4 kg squared S squared. So it gives us a different way to look at it. We want to expand to impulse and momentum. So remember, I have my sum of the forces is equal to my mass times my acceleration around the center of gravity. And we can actually write it as our principle of linear momentum. So nothing new here. But now if we want to deal with the moments, that's where the new stuff comes in. And so if I do this, I'm going to get my but we can do this around any point O. So I can do the same thing around any point O. And that gives us our, this is a 1, sorry. That gives us our general. We can write the 3 scalar equations. And that gives me my mvg in the x direction 1 plus f dt is going to be my mvgy. There's my impulse. These are my momentums. I can write the same thing for my y. Oh, that should be an x. Sorry, guys. That should be an x. This should be a y. And I can get my ig omega plus so nothing really new. And if we want to prove it to ourselves, we can. So there's my object. And this is going to be the center of gravity. This is a point P, and we're going to rotate it around the center of gravity. We're going to start that VG is equal to 0. And we're going to start that MVG is also equal to 0. And we want to show that if a slab is rotating about a fixed axis, and the fixed axis perpendicular to the slab, and passing through the mass center G, that the angular momentum is the same about any other point P. So if I start out with my HP, which would be the Y bar VGY, I left out mass, X bar VGY mass plus IG omega. If VG is equal to 0, those go away, and it's just IG omega. Took me longer to write the problem than actually to show it.
And that's if what is 0?
If VG is equal to 0,
Oh,
if I'm rotating about a fixed mass or a fixed through the 6 point. And then we can do fun stuff. Of course, I like momentum. Momentum's fun, right? Okay, so I've got a slab. It's a square slab. And these are 18 inches on each side. So we know where the center of gravity is. Woohoo! It's 9 inches there, and it's 9 inches there. This is point A. We have a bullet that's going to hit our slab at the bottom there. The bullet is traveling at 1,500 feet per second. It's going to embed in the slab, and it's a 20-pound slab. And the bullet is a 0.05 pound bullet. And we're going to hit it, instead of at 18 inches, we're going to hit it at 14 inches. So it's coming into the side there. And we want to determine omega, so we know what's going to happen, right? The bullet's going to hit, this is going to go rotate around that point, right? We know that part's going to happen. And we just want to determine after the bullet becomes embedded in the plate. So basically we can break this out into a couple pieces. So we can have, this is the system momentum. Before. And we can add the impulse, and we can look at A delta T and AX delta T is going to equal MVG I omega. So I'm going to write the moments about A first. Which is going to be the mass of the bullet, the velocity of the bullet, the distance of the bullet, plus 0, is equal to the mass of the plate, velocity afterwards, the distance with respect to gravity, plus IP omega 2. And the IP is the mass of the plate. And so I have to look up the plate, and it has to be 1/6 the mass of the plate. B, where B, this is for a square slab, where B is the sides. So this is going to be 1/6 20 divided by 32.2 for my mass, I want to be in feet, so I'm going to take my 18 inches divided by 12 to give me feet and square it. It's going to give me 0.2329, and this is pound feet seconds. dB is going to be 14 divided by 12 to give me feet. dG is going to be my 9 divided by 12 to give me feet. So I've got the various components for that. We'll come back to it. We're going to do the momentum in the x direction. Momentum in the x direction is going to be the mass of the bullet, the velocity of the bullet in the x direction, plus the reaction at A, the impulse that we see at A, the mass of the plate, and the velocity of the plate after. The momentum in Y I have nothing happening in the Y. I have nothing started in the Y. So I have no reaction in the Y on my component. And then we can do the angular stuff. Okay, that leaves, so let's go back and do this one. And my IP. Okay, remember that V2 is going to equal R omega, which in this case is going to be 9/12 omega. So I can plug that in. So now the only thing I don't know is that right there. That's our unknown. So if I plug in everything, I'll plug in all the numbers. We solve for omega, and it's 4.67 radians per second. V is then just 9/12, 4.67 radians per second, and that gives you 3.50 feet per second. And if I want to solve, for AX, and I'm given a change in time, I can just plug that back into there. And you'll ultimately get that AX is negative 259 pounds.
It's like a 20-gauge shotgun stun doing double its speed.
So let's do some problems like you might see on the homework. This is a disc. It's going to be rotating when this is what we're actually going to find, and this is after 4 seconds. We want to find that after 4 seconds. Our disc has a radius of 0.5 feet. We're pulling with a force of 2 pounds. And the disc is a 10-pound disc. And we want to find omega after 4 seconds. And we're starting with that equals 0. So first thing I need to know is I/O for a disc. So I've got to look that up. This is 10 pounds. And that's going to give me 0.0388. My moment, if I just look at my moment, right? My moment is going to be the force times the distance. My force is 2 pounds. The distance is 0.5. So I can leave it like that. So if I start out with my I/O, that was 0. We're going to go from 0 to 4 seconds. This is going to be my 2 pounds, 0.5, evaluated, or this is times T, evaluated from 0 to 4, is going to equal I/O omega. We already know that. The 2 pounds, 0.4, ends up working out to be 0.4 divided by 0.0388 is going to give me my radians, and that's 103 radians per second. So now if I do a double pulley system, I've got a 40 kilogram mass. I have a force that's being applied of 2 kilonewtons. The inner radius is 0.075 meters. The outer radius is 2.2 meters. The mass of the pulley is 15 kilograms, and we're given K, the radius gyration is 0.11 meters. And we want to determine the speed after 3 seconds. So basically this is HO. And I have to deal with my 2 pulleys. Okay. And it turns out that I'm going to deal with my 2 pulleys, that I'm going to start out at 0, and I'm going to have my 2,000 pound force applied at the 0.075 times T evaluated from 0 to 3. And it's rotating that way. This one wants to rotate rotating that way, so I'm going to have, and this is going the opposite direction, so I got to go the opposite direction. So I'm going to get my 40 pounds, 9.81 times its that's going to be my mass times K squared times omega. We know the mass, 15, we know K, omega. It's a solve for omega. omega ends up being 120.4 radians per second. And the velocity ends up being r omega, which is my 0.2, 120.4. So what's initially a fairly complex problem actually simplifies greatly. Okay, so here's the good news. We have now covered all the theory that we have to cover in the semester. Yeah. On Monday, I am going to do a couple of three-dimensional problems. And probably on Tuesday, I'm going to do a couple of vibrational problems, just so you guys can see it. Depending on which book you have and depending on which course you have to have, the three-dimensional problems are some that they want you to actually have seen. Same thing with vibrational problems. So Monday, we're just going to work some three-dimensional problems, and then on Tuesday, we'll work some vibrational problems, but you will not have any homework on three dimensions or vibrations. So all the homework that's currently out there is out there. Everything that's left is out there and in Blackboard. Test has 9 problems on it, so that you guys have the ability to look at it from that perspective. So it should be, several of them are multiple choice. The rest of them are calculate and show the work. Yeah.
So to study for the test, are there certain chapters we should focus on, or is it going to be like one from each?
No, I didn't do that. As we've seen all the way even here, everything's comprehensive. I would look back at the quizzes. I would look back at, I would go and look at review problems on each chapter, because those review problems are really good. They look very similar to problems that you've seen. And when you guys take the test, don't make it harder than it is. Because that's one of the things that you tend to do in dynamics. You tend to go, okay, it's got to be complex. No, it doesn't. I mean, look at this problem. That one we could have made it a lot harder than it was. And no. And as you noticed, the hard problems really were in like the 4th chapter. When we were doing all that, when we were adding all the angular motions of a particle, that really was a lot of the harder problems, because we couldn't take into account the moments of inertia. So with the chapters we spent the most time on were like chapters 14, 15, and 16. This stuff is just extensions of that.
On the test, will it be like, will you give us like, solve this problem using kinetic energy?
Nope. I don't care how you solve it.
Just as long as you get the right answer.
Because, and that's the other thing, some of these problems, solving it by kinetic energy works. You could solve it multiple ways. I mean, how many times did we do the ladder problem this semester?
A lot.
We did the ladder problem a bunch. We also did that example of that one piston problem. We used that piston problem for about 4 or 5 different things, depending on what the question was that was being asked and the information that we were given, which way we wanted to work it. So if you think through some of that, how many times did we roll a cylinder down an inclined plane? A bunch. How many times did we look at a wheel? How many times did we pull something off of a pulley? Those they're nice problems to work, and they're certainly simple problems to be putting on for a short time duration test. So I'd be looking at the review problems. I'd be looking at, it's open book, open note, calculator. I do give partial credit, so that's good. And I'm basing it out of 200 points, so there's lots of partial credit points available. And I will tell you, most of them, I did not provide you a diagram. So, as my normal rule, for those of you who haven't had me before, my normal rule is if you draw a good picture, you're at least going to get a point. and 6 of the 9 problems do not come with pictures. Now, you should be able to draw the picture from the problem, but 6 of the 9 problems do not have a picture. Hey, any questions from the peanut gallery over there on the computer? Okay, we'll see you Monday. And Brandon will look and figure out what's going on with yours.